Hello, mathematicians, puzzlers, and other curious people. Another kind of data display is a histogram, and you can use a histogram to investigate lots of interesting things. But what is a histogram? Let's look at how to draw one. So a histogram is a type of bar chart. You can see a very simple bar chart if you turn your head or turn the numbers and then relax your eyes or sort of smudge in the numbers here. So we could have a 2-bar chart by using these two stems. Even though that was easy, it's not very informative. For one thing, we only have 2 categories in it, and that means that we're not breaking it out very far. How many should we have, though? That's a big important question. In general, when you're drawing a histogram, you like to have about as many categories, you might hear them called bins or classes, as the square root of the number of things in your data set. I see that 35 is really close to 36. Why did I choose 36? Because the square root of 36 is a whole number, 6. So I'm going to break this into 6 evenly spaced categories. Let's take a look at what those categories will be. So I want my first category to start at my minimum. That's 0. What do I want it to go up to? Well, I definitely don't want it to go up to 15 because that would put everything in one category. I want my maximum of my last category to be close to my data set maximum. So I'm going to choose a multiple of 6 that's a bit more than my maximum. So 15 is a little less but pretty close to 18. So I'm going to use an implied overall width of 18 and divide that by 6. So I will make each category 3 wide. So I'll start my second category at 3, my third at 6, my fourth at 9, my fifth at 12, and my sixth at 15. Then I will go up to just below. Now, if you're using a data set with decimals, you might use 2.9, but since I've got all whole numbers, I'm sticking with that. And you'll just stop right below the next. When I say below, I mean numerically, so just barely less than the next. And you notice these are each going up by 3. 14 and 3 is 17, not 18, but that's okay because we chose 18 because it was rounding up. So now we need the count of what part of the data set is in each category. So 0 to 2s, I see that that is 6 items. 3 to 5, I see that that is 8 items. 6 to 8, I see that that's 6 items. 9 to 11, I see that that's 5 items. 12 to 14, wow, that's a lot. 3, 4, 5, 6, 7, 8, 9 items, and 15 to 17 is only 1 item. Whichever category has the greatest count is what's called the modal bin or the modal category, or you might also say the modal class. Whichever way you're saying it, modal means whatever is the most. Just like the mode is whatever single number is repeated the most in your data set. Now this isn't a histogram, so I see I need to be able to go up to 9. I'll start with 0 right there. 2, 3, 4, 5, 6, 7, 8, 9, 10. If I were going all the way up to 10, I'd move that down because it's bumping that, but in this case it doesn't matter. 5 will be there, 10 and 15. So my 0 to 2 bin, I'll actually stop here at the 2.5 point because in a histogram we make them nudge right up against each other. So that'll go up to the 6, and then I need to go up to the 8 in the 3 to 5 bin, and then 6 again for the next one, 5 for the one after that, 9 and 1. And that is a histogram. Some people like to fill these in with different colors. That's optional, but it can help with if you're trying to make some particular point. So that is how you can draw a simple histogram from a data set. Just one more thing. There are a few different ways you can label these. This is an absolute histogram. If I wanted to draw a relative frequency histogram instead of an absolute frequency histogram like this, I would need to do a couple more things. So one thing I can do first is add up what's in my categories. 6 and 8 is 14, and 6 is 20, 25, and the other 10 is 35. So the count is also called the frequency, and then the relative frequency is just part out of whole. So 6 out of 35, 8 out of 35, and so on. And people often like to express this as a percentage. So keeping in mind that part out of whole is just a fraction, and a fraction is just a division problem in disguise, I'm doing 6 divided by 35 is 0.1714, etc., about 17%. And I'll use that result in two places. 8 out of 35, so 8 divided by 35 is 0.228, etc., so about 23%. 5 out of 35, so 5 divided by 35 is about 14%. 9 divided by 35 is about 26%, and then 1 divided by 35 is about 3%. 17 and 23 and 17 and 14 and 26 and 3 adds up to exactly 100%. So that's a good reason to believe that we're doing pretty well so far. We can use these relative frequencies to draw a relative frequency histogram. So I see we need to go up to a little more than 25%, so I'll say we'll go up to 30%, and I'll count by fives. So we'll have 5, 10, 15, 20, 25, and 30%. We'll have our same categories, so we'll have very similar marks across the bottom of our bar chart. You can see by visual inspection that that's very similar. So then our first percentage was about 17%. Well, that's a bit more than 15%. And again, we're not going over this with a millimeter ruler, we're expressing information. Then 23%, okay, well that's between 25 and 20, a little closer to the 25. The next was 17%. So 14%, well, a little less than 15%. And then the 26%, so a bit more than 25%. Last but not least, 3%, so somewhat less than 5%. One thing we can notice by looking at this is it's basically the same bar chart, just sometimes because of how you rule it off, it gets a little bit compressed or stretched. If we stretch this up, it looks very, very similar. So that is how you can draw an absolute frequency or a relative frequency histogram. Calculator!